So good morning, everybody, and thank you for joining me today. This beautiful morning. The TV says there is snow outside, but I think it's rain, and they are wrong. So it's safer to be indoors. Today I will be talking to you about R, and if you are more interested in GitHub commits, if that was the subject that drew you in, I recommend to see Johannes yesterday's talk. I will be focusing more on R itself than GitHub. Of course, this will be my data set, but not necessarily something that will be bringing focus to this talk. So who am I? I'm a software developer, and recently, because I was dragged to this data science, big data world, I decided to start introducing this word to myself by learning another programming language, hence R. And this is how this talk was created. I don't have anything like really pink on me, but pink is my favorite color, hence this gig word there. So, what are we going to talk today about? I'll talk briefly about the R ecosystems and go through our basics, and then I'll walk you through how did I manage to analyze some GitHub commits. And there will be a lot of code, so I don't know if that's the best way to draw your attention, but yeah, prepare yourself to a lot of code. And I decided to put this code on slides, not to show you the code in editor on any IDE, because I used to do it and I failed miserably. There is always something that will break unexpectedly. So this is why this form about code on slides. So what is R? R is a language that is great. Everyone loves it now. It's very hip. And I like it too, but it wasn't love of the first sight, because it's a horrible language. R is great for exploratory data analysis, for visualization, for getting to know your data, for data transformations, for machine learning, but it's not an easy language. And in a second, you will see what do I mean. It was created by those two guys, Ross Ihaka and Robert Gentleman. I'm not sure if I'm pronouncing those names properly, and one of the theories is this is why our name, this is from where our name came from those first names, first letters. Another theory is that there was an S+ language created by Bell's Labs, and R was a free alternative, an open source thing. So, what about R and how can we work with it? You can just download R, install it. It's cross-platform, it's free. You can just use it with any editor you want. But there is also an IDE. I wouldn't call it nice, but it's the best you can get for free and for R. So this is our studio. This is basically how it does look. This is an editor. You have tabs, you can create files, and this is a console. And the thing with R is, whenever you have stuff like this, you need to run them and they will appear in a console. That's how it's done. You're not running a file, you're running commands. This is a very nice window with environment variables. So whenever you're creating something, it will appear here. So if you just want to have a quick look on your local variables, you can have them here. And sometimes you just need to know what type it is, how many, what length it is. All those information will be aggregated here. And this is a very, very busy window. So if you could see here, you have files, you have help. Whenever you want help, the HTML will be rendered here. You have all the packages, you have plots, and whenever something cannot fit here, it will end up here. So, our basics. Let's start coding. Remember I told you it's a horrible language? So this is like the basics, just types. So I created my character. I assigned a value A to it. Assigning is an arrow, by the way. You can use, I don't know why. Can you hear me better? Can you still hear me? Yeah. But my breathing is not there. Might be this. So, this is my character. I assign value A, and I display my character. And there is this 1 in brackets. Because everything in R is a vector. Even if it's just one value, it's a vector. And this 1 says, you know, that's not just an A. It's a vector with first element of an A. But the type of my character is character. It's not vector of characters. Okay, I can have numbers. The type is double. And R is a dynamic language, so even if I had a number there, when I put there some text, I can easily change a type of my variable. R doesn't care. And R does all of the castings for you, almost all of it. So if you start working with R and you just read some data and just put some values there, don't be surprised when R does some casting for you, some conversions, doesn't tell you about them. So what are vectors? Vectors are like arrays in any other programming language, maybe not any other, but like arrays in Java or in C#. And it just aggregates elements of the same type. You cannot put elements of different types in a vector. If you try to use it, like A, 1, and C, R will try to convert it to strings, probably, because it's the easiest way. And type of the vector is, again, character. You might notice that when I display the vector, I still just have 1. Why is that? I have 3 elements now. I was confused for a long time. It's just, it will appear, there will appear different number if we just run out of space. If I have a lot of elements in my vector, there will be like another thing here, and you will see it in next examples. But this was really, really confusing from the beginning. You can create vectors in many ways. This stands from combine. I think it's combine, but no one wants to write this big name of the function, so they shorten it to C. If you just want a sequence of numbers, you can just use 1 to 10, and if you just want, it should be 10 here, not 0. If you just want default values, you just use the name of the type and number of elements, and then you have default values. In case of numbers, default value will be 0. In case of strings, it will be empty string, etc. So you can concatenate vectors as you want, and there is a very nice trick if you just want letters. So if you display this vector with letters, it will display letters from A to A, B, C, D to E. You can also access a specific element of the vector by just using brackets. Lists. Lists are just horrible. Just look, I just created a list. List is different than a vector because you can gather together elements of different types. But when you try to display this list, you have those horrible brackets. I couldn't really get over it when I was first looking at it. And when we try to find out about the type is list. Because we don't really know what's inside, and R doesn't care. So this is the first element of our list, as we can see here. This is the index of the first element, second element, third element, and it has double brackets. because that's how lists are created. And this first element contains a vector. Surprise, surprise. Because if you go down, down, down to values, there are always vectors. There are better ways to create your elements, and if you put names to them. So if you have vector, you can put names to a specific element, and vector can appear like this. And with lists, it's much nicer because we don't have those horrible double brackets, and it's kind of cleaner to look at it. And if you think of it, if you think of lists and having any element you want, lists are kind of like objects. Instead of dot or arrows in C++, you can use this dollar to access those elements and create nested structures. Maybe not like objects, but like structures. If you want to access the elements, you just use brackets on vectors, double brackets. You can use double brackets on vectors. R just doesn't care if it's a vector or a list. You can use names. And with lists, if you use single brackets, you get the whole element. So in case of this list, you would get the whole element. In case of named, you get this with the dollar. If you use double brackets, you get the value inside, not the whole element, but the value. You can access it using the name, but the best way to access elements on the list is using dollars. This is why I encourage you to use names on lists. Data frames are our most used data structures. And if you don't know what data frame is, you should think of it like a table in a relational database. So we have columns, we have rows. Every column has its type. So that's the thing. All those elements in this column needs to be the same type, although types of the columns can differ. If you look at the type of the data frame, it's a list. How to create a data frame? You just specify columns, or there are some functions that can convert some other structures to the data frame. But with all those constraints, every column needs to have elements of the same type. This is a very useful function. If you want to just have a quick look on your data, imagine your data frame is much more complicated or bigger than this one, but you want to make sense, first look on the numbers with your data. You just run summary, and you have, out of the box, first insight into it. If you want to use functions to the specific elements, specific columns, basically, if you can imagine there is a function that does something, min, max, sum, there's probably some function already implemented in R. Just try to use it, and there is a chance it will work. So how to filter vectors? So sometimes we want to find elements. Let's imagine we have a vector of numbers from 1 to 10, and if we want just elements bigger than 4, this is what we write in brackets. Ta-da, magic. We have our list vector that contains only elements that fulfill the condition. You can use more complex functions. You can even put these functions inside. Or you can use filter function. Sometimes it's just cleaner to use filter function, and you will see that in a second with my example. With data frames, let's assume we have this data frame. There are several ways of filtering. So if you just want one column, we just want column age for genders that equals female. This is how you do it. You just put it into the brackets. your condition. Again, you can use more complicated conditions, more complicated functions that will just return some logical value. You can also say that I just want elements from 2 to 4, or even some elements just by indexing them. Or I just want elements where age is less than 30, or gender is male. Notice this comma. If you forget this comma, the R will return you some weird values, and you won't know why, unless you really, really understand what's under the hood of R. It just tells R that we want to filter by rows, not by columns. So rows, after a dot, after a comma, you can filter by columns. So you can just put data frame, I just want third column, and I have my column. I want columns 1 and 3, or 3 and 2 in this order, or by just referring to their names. Okay, let's do something. Let's go to GitHub and try to analyze something. So what I wanted to do is language distribution, see how popular are languages. And I use GitHub Archive as a data set. So if someone was at yesterday's talk of Johannes, they were analyzing millions of those. We won't do that today. I will just show you how I analyze an hour of those data. So you can just go to GitHub Archive, you can just download any hour you want, and you can have you can get a file with different types of events depending which events happened. And at the moment, from 2015, all those events have the same structure with this one but. The structure is like author, repository info, and payload. And payload is different according to different types of events. Okay, there is another data source you can work with GitHub Archive. So one is you download all those stuff, you put it in your database, and you analyze it, or you just use Google. Google puts something that is called BigQuery, and they already did the job for you. But it's paid. First terabyte of the month is free, but you can imagine how much data there is for GitHub. So this is a simple query, an example of a query. So you could just get repository name, URL, and language for those types of events for an hour on 1st of January 2015. And you can download those data, but if your data set is small. If your data set that you want to download is too big, they ask you to create a table, which is paid. But that was a little digression, we won't do this. It's just for you to know if you want to do serious analysis. So what are we going to do? We are going to analyze an hour-long, 3 p.m., 1st of January 2015 events. And what I did find out after reading all the internet, Stack Overflow questions, other projects that were claiming to analyze GitHub archives and do the language distribution. At least for 2015, there is no language information in any event except pull requests. So only in pull requests we have language information. I have no idea why. And during this hour that we're going to analyze, there is like 11,000 of events. Only around 500 of them are pull requests. And then I thought, well, is this analysis actually true? Will it give me a proper information? Well, I'm not a statistician and I'm not claiming, so I'm actually disclaiming to you what I'm going to do. But I'm not alone in this world. Recently, there was this article, you probably heard about gender bias, how women are better coders, but only if they don't reveal their gender. Anyway, that might be true, I don't know, because what they did, there are like 4 million of GitHub users. They only were able to discover 1.4 something genders, and this was their primary data set. So this was only 35.3% of users that they took into account. And if you look at the amount that women versus men are committing to GitHub, I'm still not convinced. But I'm not a statistician. I'm not saying it's not true. It's just I'm saying what I'm showing to you. So this is how the file looks like. So we want to read it, make some sense of it, and basically count the language distribution. So what we need to do, we need to read our file. This is the simple function that can allow you to read a file if you have a CSV file. But we don't have a CSV file. So there is another function that is called read lines. So going back to this file, we could read lines and then use some JSON library to convert it to some useful information. And if you probably don't see it, but yeah, because it's not the beginning of the file, but it's not a valid JSON structure, this whole file. Lines are valid JSON structures, but it's not a table, it doesn't have a comma after every JSON. So you actually need to read it line by line and use some JSON converter. If you want to know how to write stuff, there are plenty of write functions to write to, for example, CSV files, or TXT, or whatever file you want. Just CSV are the most common. And there are some functions that you can use to apply. And why I'm talking about that? Because after we read those lines of JSON, we need to apply some JSON converter to them. So that's basically my idea how to approach the file. There are two functions, sapply and lapply. They both differ because they create different structure. Sapply is creating a vector. Lapply is creating a list. And the question is, what do you want to achieve? If sapply failed to create a vector, for example, your data source is a list, it will still create a list. So this is my code, how I analyzed, how I read the events. So I wrote a function. This is how you define a function, basically. I read the lines from my file, and I applied from JSON. This is a function from RJSON library. You can use any function you want, to be honest. And I got my JSON events. So I have in my JSON events a list or a vector, depending what my lapply. This is a list of structures that was taken from every line of this file. And then I looked at RStudio. That's how I knew there are around 11K of elements. And this is how I filtered only pull requests, because this is what I wanted. I didn't want any of my other events because I knew there is no language information. But yeah, when you're doing stuff like this, you really, really need to be careful which information you're giving away, so people are conscious and know what are the data distribution, what the data distribution is for the data that you're just rejecting. So this is this dollar thing that you could get into the structure. Our elements, our events have a type, and type is like create event, pull request event, etc. And this is in, which is a syntax for checking if something is the element of the list or a vector. So if I put here as a parameter, if I put in a second, if I put pull requests, And this is how I can run this function. Okay, so if we use this function, we will read only pull requests events. Let me tell you something about missing values. So in R, you have nulls, and you have also missing values, NA. And missing values can appear in different ways, usually when a conversion between type was unsuccessful. Or you can use it when you just think, this is my missing value, and this is what I need to and want to point at. So you can just create a vector with this missing value, check if there are some missing values, if there are some, or where are those missing values. You can even set your missing values. What am I doing here is saying that in my vector A, I want to element 2 and 4 to be set as a missing value. And this is like weird. I don't know. Like any programmer could. No. Okay, there are also null values, and they are different. And null values are created also sometimes from reading files from some external data. I am not really sure how R is interpreting most of the files. So if you just want to look for missing values, look for both. And in terms of strings, also looks for empty strings. But this is the same in every language. So I'm reading my events. I'm putting pull requests event because that's the name of the type. And I have some file name already done. What I need to do is take an ID of my repository and the language of my repository. So you could imagine how nested this structure is. And this is ID of my repository. And this is language of my repository. And this is something that took me, I think, 3 hours. I didn't know what is happening because sapply was creating a list, not a vector, and I was expecting a vector. And then after 3 hours, I had a breakthrough. So some languages here appear as nulls. So it's translated as an object, as a list more than a vector. And if I don't put a normal vector value there, sapply will create me a list from this function. If I check for nulls and put a real a character value, it will create a vector. Like seriously, that's R. It's just for you doing stuff you don't know, don't understand, but it's there, and you don't have to think about this until you need to think about this for 3 hours. So we just use sapply with this select function. You could easily just put this function in here, but I don't know if that's clean code and if that would be clear for anyone. And this function in this way, of course, can be reused. So now we have our pull requests as a vector of values ID, and language. What I want to do now is to create a data frame. So I could just go through those pull requests and just rbind, which means bind a row to my data frame for every element. Or I could create 2 columns and add my ID language to both of those lists, and then create a data frame. But there is an easier way. You could just name the columns of your pull requests, and this way we have our data frame. And we can look at the head because it has around 500 elements, so we probably won't be able to look at all of them. And we can run summary. So head of our data frame of our ID and language looks like this, and summary looks like this. And then I have noticed that some of the repositories are there a couple of times. Why? You don't want to talk to me. Because there are several events, several pull requests to the same repository. And there is the decision for you to make. If you want to just do the language distribution, which language is more popular than the other, do you want to count all those appearances, or do you just want to count it once per repository? Both of those decisions can be true. I mean, you just need to make it and go for it. I decided I just want to count language once per repository. So I figured there are several rows that are the same, and there is a simple way to do it, to recognize it. There is a function called duplicated, and just returns a vector of logical values and just says to you which elements are duplicated. But if you look at them, I have element 3 duplicated, right? And element 2. So I was expecting this and this to be true. But true is only on the duplicated element, on the second one, on the third and fifth also. But first time the element appears, this function will not return a true on it. Beauty of R again. But if you just want to know if there are any duplicates function is for the win. But if you just want unique elements, which I want for my repositories, IDs, and languages, surprise, surprise, there is a function called unique, and you can just run it, and there you go. I just ran unique function on my repositories and did the summary. But there are still some repositories that appears twice. Why? Why do you think there is like that? Yeah, some repositories can have 2 languages. Like when you run GitHub API on my repository on R, this one that you can find on GitHub, it has R and it has Rebel. I have no idea what Rebel is. That's fine, because I want to have a language distribution, right? What are distribution tables? If you know, just ignore me now. If you don't know, it's basically something that counts occurrences in different dimensions. What do we need at the moment is to count the occurrences of languages in my data set. So if you imagine a collection like this, and I create a table, and I display the table, it just counts how many occurrences of A, B, and C is in my data set. If you run attributes on the table, you can have some more meaningful information. So if you just run table on the languages and then look at the head, you see action script, occurrence 1, blue spec occurrence 1, C9, some random data from the head, and you could notice that there is nothing here. What's this nothing here? No, those are missing languages. Remember when I replaced the null with empty string? This is it. And there are quite a lot of them. So I then sorted it and have seen that like the most popular language was Python, but this no name missing was 27. So I have 27 out of 500, which is basically 5%. I don't know 5% of my data on top of those 10.5K I already rejected. Sort, again, a function that you could just think out of your head exists in R. So what you can do, you can just, filter it out. I just rejected it. I only want languages that name is different than empty string. And this is again a decision you could make. If you want to include this in your final report or in your visualization, you could. You could just say, well, out of those repositories, those are the languages we don't know. might be a valuable information. I decided to reject it because it's just me learning R. I used the table again, and I sorted it because I want only the most popular languages. With sorting, you need to set decreasing as true because as default is ascending. There is a function called names, so I could just have a look on my languages. Of course, with bigger data set, it wouldn't be that easy, couldn't fit it on one slide. But can you see this? I still have this language, empty string. And none of the people who are working with R daily basis could tell me why. It just somehow remembers. The occurrence is 0 now, not 27 as it was, but it's still there. And this is my final plot. So I just took languages that has occurrences bigger than 5, so it can fit nicely in a slide, and use bar plot for visualization. It's like one of the simplest plots you can use. The simplest plots you could use in R looks a little bit like Excel plots, Excel graphs. So they are not very nice, but R is very good at visualization, but it's a separate talk of mine. So I'm not going into much details, but if you're interested, just go for ggplot libraries, and they are just amazing, blowing up your mind. So, as a summary, we talked a little bit about GitHub Archive, and I've shown you me and my journey through how did I know my data set. But in the meantime, I talked to you about a lot of syntax of R. So data types, some conversions, filtering, I/O operations, applying data, and missing values, duplicates, binding data, distribution tables, and just a little bit of plotting about bar plot. So if you have any questions, I think we still have like 3 minutes. Yes? How long did it take me? So my first version, I was supposed to give this talk on some users group. It took me like 5 to 6 hours. But first solution, if you go through my GitHub history, wasn't very good. But like 6 hours. And since then, I was talking to people, I was giving this talk, and got a lot of feedback from people who are using R, but not for GitHub, just more for machine learning. And I couldn't count all those other hours. But like first draft, first working something, around 6 hours. Do I think in 8 hours I could be productive for some? I'm sorry, I didn't get that.
You said it took you 6 hours for this first thing. So like in 8 hours I could be productive in some work task.
Right, from 0 to some task. Yes, but it depends. If you got stuck in some weird errors, and I didn't tell you about that, but those errors in R doesn't tell you anything. Then they tell you some message, and it doesn't mean completely anything, and it's not connected to what you would expect. There is, and even if you Google weird R language errors, there is a whole page of errors like that, and they tell you like, this could mean one of those 5 elements. So if you're stuck with a weird error that community doesn't have an answer to, then I don't know. But with some work task, with some data analysis, with using machine learning algorithms, yeah, definitely. Although you can see it's a weird language, and sometimes it can drive you crazy with all those brackets and conversions that happens behind the scenes, and you're not aware of them. Any other questions? Yeah? So in my opinion, yes, the question was, machine learning is one of the fields R could be useful what are other fields that I think R is good for? So other than machine learning, visualization, actually Microsoft bought the company and now is including R in the newest SQL Server for visualization. And don't judge by this, but some of the graphs are just amazing. So visualization, and first of all, exploratory data analysis, which elements I was trying to show you, but I was trying to show you more syntax of R than this analysis. So stuff to get to know your data, get to know your structure, find out the missing values, fill in the stuff that you have missing. So working on the data and exploring your data, R is very good for it. Any other questions? Yeah? So how easy is to use it from other languages? I had this theory, I'm a C# developer, daily basis. If something is easily done with C# and .NET, it's easily done with anywhere else. So basically there are libraries that are just adapting input and output for R. You can just run R code from some other language. And this is how I think R should be used. R is not like Python. It's not a language for everything. It's very good for some specific areas, and you should have your system written in some normal language, and then use R when it's good for. Any other questions? No? So thank you very much for joining me.